Hey Goobers, and welcome back to class. So today we are going to be learning a lot about composite figures and how to find the area of them. But first of all, we have to know exactly what a composite figure is. A composite figure is a shape that has been made up from several different simpler shapes. So a shape made up from simpler shapes. So when we think of a composite figure, that can be a little difficult just from definition to think of what it is. So simple shapes are basically rectangles, triangles, and circles. There can be more, but we're going to focus on those. So when we think of these composite figures, we can think of something that looks like a house. So with a rectangle on bottom and a triangle on top. If you were able to get rid of this middle line here, and it only be this outer edge, or the perimeter of this figure, that would be a composite figure. So to be able to find the area of composite figures, we're just going to basically pick apart the shapes that are within it and find the area of those shapes. Again, I know that sounds confusing, but it'll make a lot more sense as we get to the examples. But before we get there, we want to go over and recall the formulas for the area of these simpler shapes. So a rectangle, we can remember that the area equals base times height. It's probably one of the most simpler ones to remember, but is very simple. The base times the height, the two different measurements. Where a triangle is area 1/2 base times height, or area equals base times height divided by 2. And that is because two triangles put together will make a rectangle. So half of a rectangle is a triangle, so half of the rectangle's area is how you're going to find a triangle's area. And then the circle's area is pi r squared. This is the one that's the most different from the other two, so it can be a little bit more tricky to figure out, but its area equals pi r squared. So now that we have these, we're going to move on to our example, and this is going to start making a lot more sense now. So as we can see here, this shape is our composite figure. It is made up of half of a circle and a rectangle. So we are going to use the area formulas of a rectangle and a circle to figure out the area of this entire composite shape. So when we do that, we want to first look at what the simplest item is. And as I said before, the rectangle is probably the easiest to remember the formula, so I know I personally like sticking with this rectangle. So we're going to first find the area of this internal piece here. So to find the area, I'm going to do A equals base times height, which is A equals 15 times 10, which when you multiply those together, you're going to get 150 inches squared. So that is just the area of that rectangle. I'm going to match this highlight here. So the highlight of yellow is just the area that is shaded in yellow for our figure to the left. But we also have to figure out the area of the circle portion of our composite figure. So this green portion I've just highlighted here. So if you remember that circles have an area of pi r squared. Now here's the thing. To find the radius, we have to take half of this diameter, this 10 portion here. Because a radius goes from the center of a circle to an outer edge. So to find that, we have to do 10 divided by 2, because the radius is half of a diameter. So with our diameter being 10, we're going to divide 10 by 2, and we're going to get 5, which is our r. So we're going to plug this 5 in. So we're going to get A equals pi times 5 squared. And for our sake of simplicity, we're going to use 3.14 as pi and keep that 5 squared. And since 5 is the only item being squared, we're going to square it first. So when you square 5, which is just 5 times 5, you're going to keep that 3.14 because we haven't used it yet, and we're going to square this to get 25. And now that we have these two together, we are just going to go ahead and find the area by multiplying 3.14 by 25. And that's going to give us 78.5 inches squared. Now this area is the area of what would be a whole circle. So if the green shaded portion here that we see to the left was doubled, but there's only half of this attached to our composite figure. So we have to divide this by 2 to be able to find how much area that green space covers. So we're going to do 78.5 divided by 2. And when we do that, we get 39.25 inches squared. So that's the area of the green shaded portion. So what's left is find the area of the entire composite figure. So if we have the area of 2 pieces of our composite figure, we can just go ahead and add those up. So our area is going to be 150 plus 39.25. And when we add the 150 to the 39.25, we are going to get 189.25 inches squared as our entire area. So I hope by now you've kind of gotten some kind of grasp on how to find the area of composite figures and what they are. But if you haven't, that is perfectly fine because we're going to move on to another example. So in this example, we again have a composite figure that is made up of 2 simpler shapes. This time we have a rectangle and a triangle, but you can't exactly see where they're divided. So I know many students would just take a line and cross it there, but that doesn't create 2 simple shapes that we are using that are triangles, rectangles, or circles. So instead, you want to look for where a triangle would be. Here is this angled piece. So my first thought is, how can I make this angle into a triangle? And now the easiest way to do that would to take a line right there to divide this shape to create this angle into a triangle. So now that we've done that, we can go ahead and try to find the area of this triangle here. And what is left is that we have just a simple rectangle. So now in this shape, we are going to be using the area of a rectangle and the area of a triangle and combine those 2 areas to find the entire area of the composite shape. So again, like before, we're going to start with the rectangle because that's usually the easiest. So A equals base times height. We can see that the height is 12 and the base is 16. A equals 12 times 16. And when you multiply 12 and 16 together, you get A equals 192 centimeters squared for that green shaded portion. So now we're going to go on to the triangle, which is A equals 1/2 base times height. So now we know the base is 12 because the base shares the length of the rectangle. So we know that that's 12. So A equals 1/2 times 12, but we still have to figure out the height. Now, many people are just going to assume that this 10 is the height here, but that's not exactly correct, because if we remember back to area of a triangle, the height has to be perpendicular to the base. And if this line that we've created is the base, this 10 is not perpendicular to it. That does not create a 90-degree angle. So what is perpendicular would be a line that goes straight down from that very top edge. So what we end up having to do is notice that this length is part of this 24 centimeters, and the same thing as this 16 centimeters is also part of this 24 centimeters. So if we know from this portion to this portion, that is 16 centimeters. And from here to here, that is an unknown amount. And the entire thing together is 24. We can take 24 and subtract 16 from it. And by doing that, we are able to find that this unknown piece is 8 centimeters long. So if we took a measuring tape and measured from that point of the angle all the way straight down to the base to make a perpendicular line, we know that that is 8 centimeters long. So over here, our height is going to be 8. So just like before, we can multiply 8 times 12 to get 96. And we haven't used that half yet, so we have to leave it there. So 1/2 times 96. And when you divide 96 by 2 or multiply it by 1/2, you get 48. And that is the area of that triangular piece. So now we have found 2 separate pieces of one composite figure. So to find the area of the entire thing, we have to add it up together. So we're going to take the area of the rectangle, which is 192, and add it to the area of the triangle, which is 48. And when we add 192 to 48, we end up with 240 centimeters squared as our entire area of our composite figure. So now I want y'all to keep using that pencil and paper that y'all should be using to follow along and take your notes with to find the area of this composite figure. I'm going to tell you that you're going to be using one rectangle and one triangle, but finding the base length of the triangle is going to be a little tricky. So watch out there, but go ahead and pause this video and give it a try yourself. So if you've played this video, I'm assuming and trusting that you've gone ahead and tried this to your fullest extent and that you are ready to see how you did and to check off and follow along. So our first step is to figure out where the triangle and where the rectangle is in the shape that I said we're going to be using. And if you notice that this shape here almost looks like a triangle without a base. So we know that we can draw a line right here and we can find our triangle and our rectangle. So we have our triangle that is shaded in yellow and our rectangle that's shaded in green. So just like before, we got to find the area of both. We're going to start off real simple with the area of the rectangle. A equals base times height, where our base is 8 centimeters and our height is 5 centimeters. Because the 8 is this entire piece, and not this 2 because it's only from there to there, and not the 1 because it's only from there to there. So it's very important to remember. So A equals 8 times 5, and when you multiply 8 and 5, you get 40 centimeters squared for the area of that rectangle. And now moving on to that triangle, you're going to do area equals 1/2 base times height. And like I said before, the base on this triangle is going to be a little tricky because it doesn't give us the base. All we know is that the entire length that we can see here is 8, and the length from here to here is 2, and the length from here to here is 1. So if we know that these two lengths are taken away from 8 to create the base of our triangle, we can take 8, subtract that 1 and that 2 to find the length of our base on that triangle. So when we do that, that's the same thing as 8 minus 3, which is 5 centimeters. So we know that area equals 1/2 times our base times our height. We've just found out that our base is 5 centimeters. And we can see here that this is real simple for us because this is already perpendicular to the base of the triangle, so that is also 5. So we can do area equals 1/2 and already multiply 5 times 5, which is 25. So when we multiply that by the half, we find that the area of the triangle is 12.5 centimeters squared. So now that we have found the two different pieces in their areas, we can add them together to find the area of the entire composite figure. So we're going to do A equals 40, which is from our rectangle, plus 12.5 from our triangle. And when we add those together, we're going to get 52.5 centimeters squared. And now I do hope you followed along at home and found out if you made a mistake, where it was at, and if you didn't, congrats. No matter what, I feel like y'all should still be doing practice at IXL or finding practice problems at home just to keep yourselves updated on what needs to happen in recalling. I'm going to let you also know that even though our examples only had 2 simple shapes in each of them, you definitely can have more than 2 simple shapes. And sometimes it's only rectangles, sometimes only triangles. But regardless, it can be a composite shape can be made if there's at least 2 simple shapes. If there's more, that is still a composite shape and you can still figure it out. But I will see y'all later on in the week when we continue on learning math through Ms. Riddle Teaches Math. See ya!